puberty, now the secondary sex characteristics develop. So we know that the women are going to develop breasts. They develop usually a widening of the hips. The boys are going to develop facial hair. They're going to have a larger growth spurt than the ladies even. Both will have growth spurts. Hair on the face, hair in the armpits. All of those things are secondary sex characteristics. So anything that you think of that's male or female that's not the gonads is a secondary sex characteristic. We know at the cellular level, we can be even more specific. Because we know of the 46 chromosomes that you have in all of your cells, almost all of your cells, that the last two pairs are what we refer to as the sex chromosomes. So if we inherit one X from dad and one X from mom, we produce a little baby girl. 2X. So we went over this briefly when we were doing the Punnett squares. And we did sex-linked characteristics. Okay? Well, we were linking them to these particular genes. To the genes on these chromosomes, the 23rd pair of chromosomes. We know if dad has a sperm that has a Y chromosome, and the egg is an X, now we're going to produce a little boy. Simple as that. So really, when you talk about primary versus secondary sex characteristics, that's gross. That's stuff you can see with the naked eye. You can't always see the gonads, you might have to cut somebody open, but you can still see with the naked eye. But when we get down to the cellular level, it's at the chromosomes. Right, that's where we determine sex. And if we've got a pair of X's, it's female. A pair of Y's, it's male. Okay? So two different ways of looking at it there. When we look at what's going on with the guys in particular, that Y chromosome is the difference, right? Because both sexes have an X. But when we have two X's, it's female. When we have a Y and an X, it's going to be a male. That's because there's a gene on that chromosome. It's called the SRY gene. I don't really care that you know that. But that gene helps produce a protein called TDF, testis determining factor. And so during development, in the very, very early stages, we take this very primitive gonad and we start to change it just a little bit into a testy instead of an ovary. So some people look at it this way, is they think that female is sort of the default. I've heard some people, especially after they take a psychology class, they'll say, we all start female. Okay, well, that's 100% wrong. Okay? We all start right here when a sperm meets an egg. And if the sperm is an X, then we start female. If the sperm is a Y, we start male, period. But I think that's somebody who hasn't looked very much at the cellular goings-on or the anatomy, really, is we start with this. Okay? When this gene is finally activated, now it appears that that primitive gonad turns into a testing. Okay, yeah, but it wasn't female before then. It was indeterminate before then. It was primitive. Does that make sense? So we don't all start off as female. We start off as what we are. But we all start off the same looking for a while. And then guys develop into testes, ladies develop into ovaries. I've heard other people say it's kind of like this, is that the default, if you're into computers, the default is female. If you don't add this factor, we become female. Okay, that's a little more accurate. It's a little more accurate. If there was something wrong, you inherited a Y chromosome, but this gene was defective, okay, then we do have a female. Because we haven't really produced the male there. So we kind of need that gene to flip the switch. So that default business is okay, but I still would never say we all start as female. We all start as something primitive. And as we develop, we branch into male or female. Okay? All right, other fun stuff. To kind of prove that, you can look at these diagrams. So up on page 1038, you see a nice developmental diagram showing the internal anatomy. We'll do the external on the next slide. Look at what's going on inside. You notice we start about the same. It's not really male or female, it's the same. So here we are, 5 to 6 week embryo. All right, so many women don't even know they're pregnant at this point. All right, maybe they missed one period, so they're not sure if they have an irregular period anyway. So here we've got this indiscriminate little developing embryo. Little leg buds, a little tail is still in place here. The head was cut off for some reason, but the little head looks normal. Looks like you have a pig embryo or a cat embryo or a human embryo. They all start off the same, basically. And if we look inside the internal reproductive anatomy, you see there's all these tube systems. I don't care about naming them. If we were doing an embryology class, we would worry about naming them. But for right now, what I care about is look at the colors. That's what's going to help us a little more. Look, we've got this blue set of tubes. We've got this purple set of tubes. The point to take home here is we have both. They are both there. We are born with both sets of these tubes. Okay? We are born with a very primitive gonad. So there in the blue is the gonad. The orange stuff is really a part of the kidneys. They develop right next to each other. So we have both sets of these tube systems. Once we get to 7 or 8 weeks, so just a couple weeks later, that gene kicks in and things start to change a little bit. And so what you see over here is we're going to look at the male. Is that SRY gene kicks in, it starts making TDF, testis determining factor, and that affects what's going on in here. And so now you see the purple tube system starts to degenerate. Okay? It needed some other signal to stick around. And the blue system lives. It stays on. So that blue system ends up being the epididymis, the ductus deferens, and even parts of the seminal vesicle. The testes, because of some other control issues, is being pulled down from the abdomen down into the scrotum, the developing scrotum. So this happens, this pathway happens because that gene was turned on. If that gene's not turned on, or it's not present, then we go this way. And now you see, the blue tubes degenerate, and the purple tubes stick around. So doesn't that reinforce what I said before? We're the same. And then we develop male or female. We're not born female, but we are born the same. Or I shouldn't say born, because we haven't been born yet. We're not born until the very bottom diagram, and that's all differentiated. But I'm saying back in the embryo. In the embryo, we all start the same.
If the TDF didn't, like if it didn't work for some reason on the gene, but it was there, would that girl look like a guy? Like,
yeah.
Okay.
Yeah, I think that would be possible. And I don't know if that's a particular disease process, if it's got a name or not, but it certainly makes sense.
Okay.
And I know there are people who have messed with chickens. You know, that's where a lot of this was learned, so chicken embryos. I know they've messed with blocking that or adding it to a female, and they've gotten the female to grow male parts. So yeah, you get into some funky stuff. So if we see what's happening with the female, in the absence of that TDF, the blue tubes degenerate, the ovary is going to be pulled down, but not as far. It doesn't go down into the scrotum. There is no scrotum. It's a labia majora in the ladies instead. And then the purple tubes will persist and develop into the uterine tube and even the ovaries and part of the vagina. So take-home message one last time was, we start the same. We have the ability to go either direction. We need a switch. And as of right now, it looks like TDF is that switch, as best we can tell. Okay, everybody good? All right, so if we look at what's happening externally, we see something similar. We start off the same. Between 6 and 8 weeks, if you're staring at the crotch of an embryo, this is what you see. They look identical. That's why when somebody is pregnant and they want to know the sex of the child by ultrasound, you can't do it very early. You have to wait several weeks because we start off the same. So again, follow the colors for a second. You see there's this nice yellow genital tubercle. You see there's the blue labioscrotal folds. And then you see there's the pinky, purpley red, pinky red, I guess, urogenital folds. So we start off with all of that. It's not until we go past the 8-week mark, where again the TDF is brought in. We start producing that TDF. That now you see the yellow part develops up into a glans, the head of the penis. We see that the blue parts develop into a scrotum and the bulk of the penis, the shaft of the penis. The urogenital groove ends up being just this little raphe, this little line down the middle, plus a little part of the anus, so the skin around the anus. In the ladies, we don't develop the shaft of a penis. We've still got the same muscles. We've still got the same tissue. There's erectile tissue in the same areas. It just hasn't formed into a penis. So you see, the little yellow part that was the glans of the male becomes the glans of the clitoris. Ultimately, it'll be this little bit of the clitoris down here. You see that the labioscrotal fold becomes labia, the labia majora. The urogenital fold becomes labia minora. So they're all from the same parts. They're just put together a little differently. That's all. I like to just emphasize we're not that different. I mean, the few differences we have are great. Don't get me wrong. Okay, I love the little differences between us, but we're really just not that different because we develop in a lot of the same ways. When you see these people who, for some reason, think they're in the wrong sex, they're in the wrong body or something, and they want to have a sex change, well, it's not that hard to do. Look at where everything came from. Surgeons can go in and kind of fix it and put it back one way or the other. It's all the same basic tissues. Plus you add some hormones in there and you can really make some pretty remarkable changes. Not that I'm advocating that, I'm just pointing it out. That it's all similar tissue. Okay? So internally, externally, we're very similar. Little differences. Little differences when we split that switch. Now, if we look at one other part of the differences, okay, which again still starts out similarly. If we start here at a 3-month fetus, that 3-month fetus, again, here's the developing gonad. We know by 3 months whether it's male or female, okay, but we can ignore that for just a second and just call it a gonad. The gonad has this funny little attachment. You see the green line in here. This little green line has muscle fibers in it. It's referred to as the gubernaculum. Funny name, gubernaculum. But this is little tissue that develops from the bottom of the gonad, and it goes all the way down into that labioscrotal fold. It actually passes through the abdominal wall to get to that labioscrotal fold. Both sexes have this. Both sexes have this. As we get later into development, as we get into the 7th month and the 8th month, that gubernaculum starts to pull. It has some muscle tissue and it starts to pull. And it brings the gonad down. In the ladies, somehow it's programmed to only bring it down about this far. But it does do the same thing in both sexes. The gubernaculum pulls the gonad down. The gonads develop way up by the kidneys. So in the ladies, it pulls down into the pelvic bowl. That's a wonderful thing. I don't know how on earth this is controlled, but it's a wonderful thing. Because we don't want our ovaries, arguably one of your most important organs. Okay, really, I mean, you don't think about it every day, but if you think about it from a human race standpoint, we need to protect our gonads. We want to have a human race. So we don't want our ovaries to develop here where there's no ribs. Right? Your kidneys are there and your ovaries develop just below that. We don't want them to be at risk. So it's great that a gubernaculum pulls it down into that pelvic bowl. Now we've got all this good firm bone around it to protect it, plus some floppy intestines over top of it. So it's a wonderful thing. So this still happens in the ladies, it just doesn't pull as far. If I took you over to the gross anatomy lab, I could show you a remnant in the ladies. There's a ligament that runs from the bottom of the ovary, it goes through the abdominal wall and into the labia majora. It's called the round ligament of the uterus. It's the remnant of that gubernaculum. In the guys, it's only a little different. In the guys, we just keep pulling. We keep pulling until we actually pull that testes through the abdominal wall and into that labioscrotal fold. And instead of becoming just labia majora, it becomes a scrotum. It becomes a pouch for that testis. What's the reason for that? That's almost the opposite, right? In the ladies, I was emphasizing pull it down and get it in a protected area. In the guys, we pull it into a scrotum. My gosh, it's just hanging out there. Okay? It's really a great risk. But the reason for that is because the testes need to be a little bit cooler in order to produce sperm. They do not produce sperm very well when they're inside the body cavity. Okay? So we have to just take that chance. We have to pull them outside of our body, put them in a little skin sac so that air can get around it and keep it cooler than core body temperature. Now we're at risk here. One of the ways we combat that, or we kind of offset that, is the testes produce massive amounts of sperm. The ladies don't. They don't have to. They're very well protected. They can nurture and produce one really nice egg. Guys, 300 million sperm. And we're not real good at it. Like 25% of them are defective anyway. But that's kind of the trade-off. If you have a protected gonad, you can be really careful about what you produce. If you have an unprotected one, you better produce a bunch because you're going to have issues. And that's a great way to end.